I'm the math guy, Steve. Let's try evaluating this integral. So when evaluating integrals, there's a bunch of different methods, right? And so we have a bunch of different ways to try to evaluate integrals. Our first attempt is probably to try to use a U-substitution if that's possible. But there's other methods. There's partial fraction decomposition and integration by parts and trig sub. And there's just regular trig integrals, right? We have combinations of sines and cosines or secants and tangents, right? So there's a bunch of different methods to evaluate the integrals. But always try to use a U-sub first. That's what you should use. So let's try to use it as much as possible, just because it's a little bit easier than the other methods, okay? So, like here, let's try using a U-sub, right? So if we were to use it, we know there's two terms underneath this square root, so probably setting the inside of that square root, the inside part equal to that u, let that being your u, and then seeing if the du is somewhere in the problem, so somewhere in the integrand. So let u equal 9 minus x squared. Let's see if that works, okay? Now then we have to find du. Du would be then taking the derivative of both sides. We get negative 2x dx. So the negative 2 part we can kind of manufacture a little bit, but the x dx part we want to see if that's in the actual integrand. Well, yeah, the dx of course is there, right? But then the x, we can kind of pull off an x off of here. Okay, now the x squared we kind of have to deal with separately, right? So then we have u equals 9 minus x squared. Du is negative 2x dx. That would give us negative half du would be x dx. But then the x squared that's left over, we kind of have to manufacture. So let's say, okay, well, using what we said earlier, we know that u is 9 minus x squared. Then u minus 9 equals negative x squared. So using that, we get x squared is 9 minus u. Okay. So for the x squared, the extra part there, we'll put 9 minus u. So here's our sub bubble. I call it a subble. Okay. Here's our subble there, the stuff we'll use to integrate this. Okay. So let's plug them in. Plug it in. Okay, that's from that Glade plug-in commercial, right? Okay. All right. Fresh and 60. Anyway. Okay, so we end up with, we said we're going to take off one of those x's off of here, right? So the integral of, it'll be x squared times, and now we'll write this 9 minus x squared, the square root of that, we'll write it as to the half power, right? So 9 minus x squared to the half power, and then x dx. And now we have something to plug in for each part of this integral. So this gives us the integral of, for x squared, we said we're going to plug in 9 minus u. Okay, so that's 9 minus u. For 9 minus x squared to the half, we'll put u to the half. Okay, so that's u to the half. And then for x dx, we'll plug in negative half du. So now we'll put the du here. The negative half we can pull out in front because of the linearity of integral. So negative half, we'll take that negative half and pull it out in front. So this gives us, okay, negative half times the integral of this u to the half. We can kind of distribute. This becomes a little easier to integrate, right? So the integral of 9 u to the half minus, and then u times u to the half, we add those exponents, right? So that gives us u to the 3 halves du. And now we integrate. And these are just power rules from there. Okay, so it's a lot easier integral to integrate. All right, so integrating it, we get, okay, that's negative half, and then times 9 times, okay, so u to the 1 half. Remember our power rule says we add 1 to the power, divide by the new power, right? So this is u to the 3 halves divided by 3 halves. Okay, minus, and then again, same thing here, u to the 3 halves, so we add 1 to the power, divide by the new power. So u to the 5 halves divided by 5 halves. Once we're done integrating, don't forget that plus c at the end, right, which is a constant with respect to whatever variable we're dealing with. Okay. All right, so simplifying, we get negative half. This is now, dividing by fractions, we multiply by the reciprocal, right? So 9 times 2/3 u to the 3 halves, okay, minus 2/5 u to the 5 halves plus c. All right. All right, simplifying a little further, we get negative half, and this is what 18 over 3 is 6 u to the 3 halves minus 2/5 u to the 5 halves plus c. All right. And then now distributing this negative half to each, we get negative 3 u to the 3 halves plus 1/5 u to the 5 halves plus c. All right. But don't forget, we didn't start off with u stuff, right? We made that stuff up, right? We start off with x stuff. So remember, u is 9 minus x squared for this one, right? So this is negative 3 times 9 minus x squared to the 3 halves plus 1/5 of 9 minus x squared to the 5 halves and plus c, okay? And there's our integral, all right? Now again, there's a bunch of different methods for integrating, so don't forget we can always check this. Don't forget that Nike step, right? We can always check this by just taking the derivative of this expression and showing that it equals our original integrand, all right? Or we can check it by just integrating a different way and see if we get the exact same integral. Okay, as long as we don't make any small steps. So again, integrals aren't too bad. They can get complicated because there's so many different methods. But don't get frustrated. Just always try a U-sub first and then try those other methods. Okay, all right. And always remember, math